In this problem, we're looking at a 100-kilogram crate that's subjected to two forces shown here. Okay, so I want to figure out how much of a distance it has to slide before it reaches 6 meters per second. Okay, the coefficient of friction between the crate and the floor is 0.2. Now, we're going to use work and energy because I don't care about acceleration. I just care about the velocity and the position, which is what that gives me. So I'll start with the free body diagram because ultimately what I need to figure out is the unknown forces, the friction, the normal force, things of that nature. Okay, so basically to find this friction force, I need to know the normal force. Okay, there's no acceleration in the y direction, so I'll just sum the forces in the y direction, set it equal to 0. Okay, because it does not accelerate vertically. So I just have my normal force. I have 3/5 times 1,000 newtons. That should read 1,000, not 100. And then 800 sine 30. That's negative. The 1,000 is positive. Okay, and then I have the weight of the object, which is 100 times 9.8. Okay, so that gives me the normal force being 781 newtons, which tells me that my friction force is 0.2, okay, times 7.8. Now, again, my motion is horizontal here, which is why I needed to find the friction force, because I needed to find the work of all of these forces horizontally. Now, the two vertical forces create no work because there's no amount of force there's no displacement in the vertical direction. Okay, so I only want forces that have a horizontal component, which is the 800, the 1,000, and then the friction force, which we now know to be 156. So using those forces, I'm going to go ahead and apply my equations here. So it's the kinetic energy plus the work being done equals the final kinetic energy. This is the notation that the book uses. Okay, I use KE and W for kinetic energy and work. Okay. Now, initially, it's at rest. There's no velocity. 1/2 mv squared goes to 0. Now, again, the work being done horizontally, because that's the amount of displacement I have, are the 800, the 1,000, and the friction force. Okay, and I want the horizontal components of each one of those. So I'm going to have 800 cosine 30 times the displacement, S, that I'm looking for. I'm going to have 4/5 times 1,000 times the displacement, S. Okay. And those two forces are positive because it's acting, those are what are creating the displacement. It's doing positive work. Those forces are in the same direction as the motion, as the displacement. As opposed to friction, which opposes the displacement, opposes the motion, acts to the left, displacement is to the right. So I get a negative work due to friction of the friction force 156.2 times the displacement. Okay? So again, 800 and 1,000 act to the right, which is the direction of motion. Friction acts to the left, opposing it, so that one becomes negative. So that's all of the forces that are doing work in the direction of displacement. That equals my final kinetic energy, is 1/2 mv squared, where the velocity, the final velocity, is 6 meters per second. So the only unknown I have in this equation is the displacement S, which I can easily find as 1.35 meters by doing it. Okay, so again, initial kinetic energy plus the work done equals the final kinetic energy. And the work is the amount of force in the direction of the displacement. So I need to use those angles to figure out how much of that force is in the direction. And then if it's in the same direction as displacement, it's positive. If the force opposes the displacement, then it's negative.